they contribute to extensions, to the ecosystem, etc., etc. But it happens quite rarely when someone contributes to the core database engine. Tell us, like, how this happened, why you decided to contribute to the core database engine.
Okay. I think I do have to give you a little bit of background on what was the task that we wanted to do. We wanted to build a multi-tenant database. A multi-tenant database where we have one database engine, but we have multiple users who have their own dedicated resources committed to their use cases, right? You may have a client A who's running Keycloak and client B who's running some CRM software. And this software uses completely different schema behind the scenes, right? So each of these tenants basically has their own schemas, has their own tables, databases, will run different workloads, and will insert a lot of data at various time intervals. And basically what we wanted to have is a database where when one tenant is pushing a lot of data through, it doesn't have any impact on another tenant. So that was basically the main requirement for this system. And when we did a selection process, we considered things like going with plain PostgreSQL and doing stuff like what people usually do in AWS with RDS, where you have multiple RDS clusters and one for one tenant, one for another tenant, and then doing some kind of data wrangling behind the scenes so that these tenants can share their data between each other, right? With YugabyteDB, when we started looking at YugabyteDB, that was, I think, in May 2020. That was at the time when you guys released this tablespaces feature, which basically is like a really powerful take on Postgres tablespaces, where you can assign selected T servers to a table space, and those T servers can basically reside in a region. And obviously, a region is a term that is basically defined by these three properties: the cloud, region, and zone. But what it essentially means is, from the perspective of operational aspect, the table space can be either just a bunch of T servers sitting all in the same as region, for example, or they can be in completely separate regions. It's just a label that goes on T servers. So that was when we basically selected Yugabyte. We knew, okay, table spaces give us what we want. So definitely we want to go with YugabyteDB.
Okay, so now enough for cheating YugabyteDB for its good side, because eventually you came across some limitations, right? And those limitations urged you to contribute to the core database engine. How did this happen? Like, how did you end up contributing the foreign data wrapper capability?
All right. How did that happen? I told you that we were trying to build this multi-tenant database. We'll build this multi-tenant database where we had resources isolated to a tenant. And one of the use cases was that a multi-tenant platform is a cooperative platform, which means that tenants want to share data between each other, either read-only or read-write. So normally what you would do is with PostgreSQL, you would use Postgres foreign data wrapper for that. And so we started investigating that, and we first identified the problem that the list of shared libraries that is loaded when the database starts was hard-coded in the runner program. So that was the first fix that we submitted. That was to enable shared libraries to be loaded from the actual configuration that is specified in the command line with YugabyteDB.
So basically, it was the first time that there were a need to load an extension during the start, because some Postgres extension doesn't need to be loaded when it starts. It can just be loaded when used. And this one has to be loaded at the start of the server.
Yeah, the shared object file has to be basically in the shared libraries. It has to be there. So that was the first contribution. So that was a small one. And then once we could actually load Postgres foreign data wrapper shared object with the database, once I started playing with actual commands to add servers and whatnot, it turned out that none of that was supported. And that was a big one. Yeah. So basically what this thing involved, I have to say, I am not a C developer, nor a C+ developer. So that was a big learning curve. I had to basically pick this up on the job. But I had to basically investigate your whole build process, because I wanted to figure out how Postgres is actually doing things behind the scenes. I had to discover your grammar file,
And that was not easy because the build process has to build Postgres that is made for single process and to build it and link in other threads in the tablet server. So it's not a simple architecture to build.
No. So again, your team was helpful at picking up the basics about how to build a database, but eventually I was able to come up with an infrastructure in Docker to build DB from sources. So to configure it, to then build it, to rebuild it, to run tests.
Yeah, that's excellent.